Okay, last Monday, okay, we have discussed on the introduction on CI, confidence interval. Okay, what is it used for? Okay, the definition. Okay, and first one is point estimate, and the idea behind confidence interval. Okay, what it is used for, and of course how to calculate them. Okay, so we practice a few questions on the Z distribution. Okay, so as mentioned before, your syllabus is divided into 3 parts. Okay, for the CI, when sigma is known, or in other words, we are going to use the Z distribution when the standard deviation is given from the population. Okay, secondly, we are going to use the T distribution when the standard deviation is taken from the sample. Okay, and thirdly, when we are using the Z distribution again, but this time around when it involves proportion. Okay, so hopefully we can cover the T distribution and also the proportion today. Okay, if not, then we're going to continue latest by next Monday. Okay, before you go for the mid-semester break. Okay, okay, your mid-semester break is starting next week or when? I also haven't checked on the academic calendar because the Hari Raya is on Thursday and Friday. Okay, so meaning next week you still got class, right? Okay.
No, sir.
Huh?
Tomorrow.
Tomorrow start mid-sem.
Oh, tomorrow. So meaning the whole of next week, no more classes, is it?
Yeah, sir.
Okay. So because office still opens until Wednesday, so I was under the assumption. So that's your class. Okay, then meaning today is our last day before you go for the mid-semester break. So meaning you are going to resume lecture. So how long is your mid-semester break? 1 week, right?
Yes, 1 week.
So meaning class will begin resume on Monday. Sorry, on Sunday the 16th. Okay.
Yes, Prof.
So yeah, okay, never mind then. Okay, so what we have discussed last time around, okay, using the Z distribution, and I already taught you how to retrieve the Z value. Okay, given 95% CI and also 99% CI. 95, if you recall, the value of Z will be 1.96. Okay, 99% CI, if I'm not mistaken, 2.57. Okay, so actually you can memorize this number because for the Z distribution, okay, regardless what question that you get, okay, as long as you are using the Z distribution, the value of the Z value, okay, for 95 remains the same, meaning if 95, it will be 1.96. Okay, 99, it will be 2.57. Okay, and then the other common value will be 90%, which I think will be 1.64, if I'm not mistaken. Okay, but the way to retrieve the value from the Z table is the same way. Okay, if 95%, meaning 0.95, you divide by 2. Okay, and then you refer to that value in the table that is closest to that value. Okay, the same goes with 99. 99 means 0.99, you divide by 2, 0.99, and that value after you divide, you refer to the table that matches the closest one. Okay, and then it applies to the other value of CI. Okay, but as I mentioned, the common one you can refer to your textbook as well. Okay, most of the questions involve 95 or 99 or sometimes 90%. Okay, sometimes you may see 98%. Okay, so next we start with, for today, we're going to cover on the T distribution. Okay, meaning constructing CI confidence interval when it involves the T distribution. So when do we use the T distribution? In the previous chapter, okay, on the sampling distribution, okay, you were introduced on the Z distribution. Okay, sorry, on the T distribution. So T basically is under the same family of normal distribution. Z is a component or a normal distribution. So does the T distribution. So when do you use the T distribution? It is when the standard deviation, okay, is calculated or is taken from the sample itself, meaning that you don't have any information on the standard deviation from the population. So how do you know when you are going to use T or Z? So usually when you go through the questions or exercises or the example from the book, okay, it will mention specifically that the sample standard deviation. So the keyword that you are looking for will be, okay, for example, like this example here, the sample mean. Okay, so the word standard deviation sometimes is lumped together with the sample, meaning that it doesn't mention population standard deviation. Okay, so for example, in this example here, okay, a sample of 10 tires, okay, gives the mean of this and the sigma of this. So if you understand English, okay, so this sentence is referring to the value of this sigma and the mean is based on the sample of 10. So by right, okay, so we are going to use the T distribution. Okay, so the way to calculate is the same as how you calculate for the Z distribution, meaning X bar, okay, plus minus, instead of using Z, we are going to use T, okay, and then sigma over n square root, okay, but of course the notation sigma is replaced by the notation S, okay, because we cannot use the Z formula. I'm sorry, we cannot use the sigma notation because sigma notation denotes standard deviation from the population. So instead, we're going to replace the notation sigma with S. S means sample standard deviation. Okay, but the idea or the construct of the formula remain the same. X bar plus minus margin of error. Okay, so the Z is replaced with T. Okay, and then the notation standard sigma is replaced by S. Okay, so in this example here, okay, I'm going to teach you how to refer to the table, okay, to retrieve the value of the T. Okay, so this one you need to refer to the T table in your textbook. Okay, so you can refer to that at the end of your textbook here, okay, under the student T distribution. Okay, so with the student T distribution, you need to know which column that you are referring to, whether, okay, so for confidence interval topic, okay, you can see that for the student T, you have 3 rows for the confidence interval, okay, and then the second row refers to the 1 tail test, the third row refers to the 2 tail test. For the second and third row, this one is referring or is only applicable when we are doing hypothesis testing, which will be covered on the next chapter. Okay, but for confidence interval topic, the one that we are doing or covering today, this week, it will be based on the first row here. Okay, so the first row means you can see here, confidence interval. Okay, so whichever confidence interval that you are asked to calculate, the common one will be 95%, okay, and also 99%. Okay, so either this column here or the second column. So basically both are the same, okay, but the difference is the value of the sample size, okay, noted as DF, degrees of freedom. Okay, so let me go through what is the formula here. I mean, if you look at this example here, so you are required to calculate the 95% CI, and then the second part will be the interpretation of the meaning of the result that you get. Okay, would it be reasonable? So you're going to see this kind of questions in other exercises as well. Okay? Whether it is reasonable, whether it is logical. Okay, is it reasonable for the manufacturer to conclude that after 50,000 miles the mean will be 0.3? Okay, so to answer this question, you need to construct the CI first. If the value of 0.3 is within or is inside the confidence interval value, then you say that it is reasonable. Okay, if the value of 0.3 is outside the interval, okay, what do you mean by outside? You have lower boundary and also upper boundary, meaning like a range between one value to another value. So if 0.3 is located inside the interval, then you say that it is reasonable to conclude. Okay. Okay. So let's go through the calculation first. Okay. So first you are given this information. the sample size, the sigma, the mean value, and also the sample standard deviation, and also the required level of confidence, the confidence interval, 95%. Okay, then just plug in. So you know what is X bar, what is S, what is N. Okay, but how do you read the T table? Okay, so if you look at the T table here, okay, the first column is noted as DF, degrees of freedom. Okay, so what is degrees of freedom? It's basically N minus 1. Okay, for one sample, for one sample test, meaning that if you are only referring to one sample size, meaning one case at a time. Okay, because in the later chapter, in chapter 9, okay, you are going to learn on two sample hypothesis testing. Two sample means, let's say you are comparing between male and female. One sample you take from the male group, another sample you take from the female group. Okay, then meaning you have two samples, one female, one male. Then if you're going to use two samples, then the way you read the degrees of freedom will be slightly different. Okay, but in most cases, okay, like the one that we are doing for chapter confidence interval, the way to calculate the degrees of freedom is simply N minus 1. So DF is equal to N minus 1. Okay, so DF is calculated as N minus 1, means if the sample size is 10 in this example, okay, so then our degrees of freedom will be 9, meaning you need to refer to the column where the value is equals to 9. Okay, so this one, along this row, along this value, okay, so meaning 9. Okay, so you have 6 values here to refer to. Okay, so the one that is relevant to you will be under 95% CI, which is 2.262. Okay, so if based on this, okay, so that's how you read the table here. Okay, so okay, you can see from this example here, okay, quite simple to calculate. Okay, so CI X bar plus minus T multiplied by S over N square root. Okay, for X bar, sigma and N, you take directly from the question, but T here, okay, as you can see, oops, not this one. Okay, so in this slide, it's already mentioned to you how to get the 2.262. Okay, so remember 9 because your sample size is 10. So do not refer to 10 because DF is not N. DF is N minus 1. For one sample test, okay, you only referring to one sample. Okay, so a sample size of 10, 10 minus 1, 9, 195%, 2.262. Okay, so from there is how you retrieve 2.262, and then the rest is you solve the problem. So you get the lower boundary and also the upper boundary. Okay, so to answer the question here, is it reasonable to conclude that after 50,000 miles, the mean threat is 0.3? So 0.3, is it inside or outside the interval? So you can see clearly here, our interval range from 0.26 until 0.38, meaning that 0.3 is of course inside this interval. Okay, so because it is inside within the interval, so you can conclude that it is reasonable. Okay, so just mention it is reasonable to conclude, okay, if you were to write that kind of sentence. Okay, so that is how you conclude from, or you extract information from the confidence interval. Okay, so so this is how you, okay, and then another example, you are given N equals to 20, okay, and then the rest, okay, X bar 49, S 9.01. So how do you refer to the T value? So our CI is again 95%. Okay, so N equals to 20. So if you refer to the Z to your T table, you are going to refer to the value where it equals to 19 here. Okay, 19. So 19 under 95% CI, so it will be 2.093, which is what is given here. 2.093 is very simple and straightforward to refer to the T table. Okay, just make sure that you minus by 1. Okay, if the sample size is 20, then the DF degrees of freedom will be 19. So just refer to the column under 95% CI here. 95%, okay, 19 equals to 2.093. And then you can solve the problem. So that is basically the T distribution. Okay, so it's very simple and straightforward. So basically, once you understand the concept of CI for the Z distribution, okay, so unlike Z, which the value remain the same. If Z for 95% is always 1.96. 99 will always be 2.57. Okay, regardless of the size of the sample. Okay, because the sigma once you use Z, the value remain the same. Okay, but if you rely on the T distribution, okay, whereby when the standard deviation is taken from the sample itself, then you need to refer to the T value, and the T value changes according to your sample size. Okay, because if your sample size is 10, you're going to refer to 9. If your sample size is 20, you are going to refer to 19. So the value changes according to your sample size, unlike if you are using the Z distribution. Okay, so lastly, the proportion. Okay, so proportion is the same as the Z distribution, meaning you still are going to use the Z distribution formula. Okay, the only difference is that the formula, or you don't have any information on the standard deviation, okay, or the mean value. So if you compare on the previous two example, okay, you are given, for example, in this example under this tire manufacturer. Okay, first you get information what is the sample size, or what is the N value, what is the X bar, and what is the sigma, or what is the S value, the standard deviation. So you have three information: sample size, X bar, and standard deviation. Okay, but when it involves proportion, okay, the information is very simple, meaning you don't have all the three information mentioned just now: the sample size, the X bar, the sample standard deviation. Okay, so what you have is just this proportion. For example, here, the carrier, this example is given that 80% of graduate enter the job market. Okay, 45% of Burger King sales are made of drive-through. So, okay, so let's go through one example here. Okay, we're not going to, okay, we're going to skip this slide because it's not relevant to you. Okay, so how do you refer to proportion? Okay, so the notation for sample proportion is noted as P. Okay, if you recall from the earlier slide, okay, the point estimate symbol. Okay, for the population proportion, the symbol will be pi, but the sample will be noted as P. Okay, so that's how you, or that's why you see this P here. So how do you construct P? It's basically X over N. For example, okay, in my class we have 52 students. Okay, let's say I'm just giving this number, at random. So let's say out of 52 students in BEEQ 1023 group A this semester, okay, let's say 20 students are male students. So what is the proportion of male student? Basically is X over N. N means the total size of the sample. X is the value of the males, the number of the male students. So the proportion of male student in our class this semester will be 20 over 52. So and then so this is how you calculate the proportion, which is basically ratio. Okay, proportion or ratio is the same thing. Okay, so once you obtain the P value, okay, the proportion value, then the construct for CI follows this formula. Okay, rather than using X bar plus minus Z multiplied by S over N square root, you refer to this formula. Okay, the only similarity with the Z value or with the Z distribution just now is the value of Z. If you are using 95% CI, then it will still be 1.96. If you are using 99% CI for Z, it still be 2.57. Okay, but the formula to obtain the CI will be based on this formula P. Let's say P just now, okay, the ratio of male to the proportion of male student in our class, let's say lah, okay, let's say 0.2. Okay. So I just take a simple number. Let's say the proportion of male student in our class is 0.2. So it will be 0.2 plus minus Z. Let's say we are interested to obtain 95% CI. 95% means 1.96 multiplied by the square root of P will be 0.2. 1 minus P means 0.3 lah. So 0.2 multiplied by 0.3 over N. N is the number of students in the class just now. Just now I mentioned 52, correct? Okay. So divide by 52. Okay. And then you solve for it, you're going to get your lower interval and also your upper interval. So that's about it, okay, for proportion. So let's see one simple example, how you solve for it, okay. So here you are given this one example here, okay, so just go straight to this information, okay. What is the estimate of the population proportion? Okay, so basically this is the point estimate, okay. Population proportion is pi lah, okay, as I mentioned just now, okay, in the beginning of the lecture last week, last Monday. The point estimate for population proportion pi is P. Okay, so once you obtain the value of P, meaning that P is based on 1,600 divided by 2,000. Okay, so construct 95% CI. Okay, can you conclude that it is so this part here is similar to the tire example just now. If the value of the proportion is within, then you can say that it is reasonable or necessary, something like that. Okay, so first construct the CI. So first, of course, construct the P value, okay, the proportion value, which is X over N, and here you get 0.8. Okay, so step number 2, you are required to construct based on 95% CI, which is 1.96. Okay, so how do I know 1.96? Go back to the last Monday lecture. Okay, I already shown you several examples on that. Okay, and then lastly, construct the CI based on the proportion formula. So if you look at this example here, okay, if you do not know, how do I know that this is a proportion question? Okay, so if you compare to the previous two examples on Z value and for the T distribution, okay, as I mentioned, for the T or Z distribution, you are going to be given the value of the mean, X bar, what is the standard deviation, okay. So in this particular example, okay, you're only given the size of the sample, which is 2,000, and then the X value, meaning that the value that you require to calculate the value of P, so X over N. So you can see here, the information is very straightforward, is very limited or very simple. So if you see this kind of question, information given, so and you need to construct the CI, okay, automatically you are needed to calculate the, in fact, from here you can see already, okay, calculate or develop the CI for the proportion, okay. So, okay, so automatically you know the formula that you need to refer to. Okay, so here the Z value is of course 1.96. Okay, so you know that P is 0.8 just now, you solve for it. Okay, so 0.8 multiplied by 0.2 divided by 2,000, make sure 2,000, okay, not 1,600. Okay, because you have two values, X and N. Make sure that the N value is the one that you divide the denominator, okay, the N. Okay, and then you solve for this, you take the square root, multiply by 1.96, okay, and then minus or plus with 0.8. So you have the lower value and also the upper value. Okay, so the question, the second part of the question, can you conclude that the necessary proportion so the this one. Okay, I'm just trying to figure out the answer for this. Based on your decision on this sample information, can you conclude that the necessary proportion of BBA members okay, this one, at least 3/4. Okay, Okay, 3/4 means 75%. Okay, so here you need to refer to the statement here. Okay, 3/4 means at least 0.75 must favor or must support the merger plan. Okay, 3/4 means the proportion must be 0.75. So what is our CI? Does it include 0.75 or not? So if you look here, okay, 0.75, the okay, so the proportion, okay, our CI, okay, they say at least 0.75, okay, and our proportion shows that the interval is between 0.78 and 0.8, or meaning between 78% up to 81% favors the merger, meaning yes, it is above 75%. So you can say that it is, we can conclude that okay, so we can conclude that the proportion members favor the merger. Okay, because here it mentioned at least 75% must support the merger. Okay, so based on this data that you construct the CI. Okay, and we find that the confidence interval, okay, is between 78 to 81%. Means that, okay, those who support for the merger, okay, is above 75%. Okay, so that is just the second part. The main thing is, of course, the ability, I mean, the requirement for you to calculate the CI. Okay, so how to construct CI for the Z distribution, for T distribution, and then the third part is for the proportion whereby you still use the Z distribution, but the formula is slightly different. Okay, you based on this one. Okay, P plus minus Z multiplied by P multiplied by 1 minus P over N squared. Okay, so I think that's it for chapter confidence interval. Okay, so since next week you are going to have your mid-semester break, okay, but as usual, okay, in order to test your understanding on this, okay, because your next or your final test, okay, before you have your final your two assignments, your two group assignment, you're going to have another test, okay, which will cover the topic of CI, confidence interval, as well. So I need to know that you are able to solve those questions. Okay, so let's see which questions are relevant, suitable for you to do. Okay, and again, I will set the deadline by tomorrow evening for you to submit. The way to submit is the same way. Okay, take the screenshot of your assignment, put it in a document or PDF file, okay, and then send it to me lah. Okay, on your OL. So I will put up the link as usual. Okay, later by this afternoon. Okay, so let's go to the chapter exercise. Okay. Okay, so the question that that I need you to submit, okay, because this question is pretty much simple to calculate. Okay, if you are using the Z value, if 95% is, then it's just 1.96. Okay, but if you're using the T distribution, okay, so the way to, for example, if you look at question 31, okay, 31 has answer at the back, so I'm not going to give you this question lah. Okay, but if you look at this question, okay, so are you going to use Z or T? Okay, so if you look here, okay, the sample is 40, the mean length of the sample is 8.32, and the sigma is 3.07. So if you look at this statement here, okay, so clearly that this one refers to the to the T distribution, because this information belongs together with the mean sample of the mean length of the sample, this, and the sigma is 3.07. So by right, based on this information, you need to use the T distribution. Okay. So in fact, most of the questions from the exercise, okay, are referring to T, because that is what in the real world example, most people will end up using the T distribution, okay, not the Z distribution. Okay. So okay, so the first question that you need to do will be Okay, question 28. Okay, so here again, okay, I can already tell you in advance, okay, that you are going to use the T distribution, okay, because the information points to a T value. Okay, the sigma here refers to the sample size. Okay, so the first question is question 28, and then the next one will be okay, question 30. Okay, here is also T lah. You can see that the standard deviation of the sample. Again, so this is also the T distribution. Okay, so question 30, so 28, 30, and then okay, and then question 34. Okay, here we got the second part. Okay, is it reasonable or not? Can you justify? So look at this value if it is inside or outside the interval. Okay, so 34. So 3 questions. So the first 3 questions are all based on the T distribution. 28, 30, and 34. And let's find maybe 2 questions on the proportion. Okay, so you for the proportion indicates okay, question 44, this is on the proportion. Okay, and also 42. Okay, so I think that should be it. Okay, 42, 44. Okay, the first 3 questions are all the T distribution. Okay, so question 30, 28, 30, 34. So the first 3 questions are on the T distribution, and then 42 and 44. Okay, I want to add one more question on this raw data here because I want to see that you are still you still remember how to calculate the standard deviation. Of course, you can use your calculator or the online calculator. Okay, population mean. Okay, question number 40. Okay, so here you are required to calculate to construct the CI for this data. Okay, so of course when you do like this, obviously you need to use the T distribution. Why? Because here you need to develop or calculate manually what is your X bar and then what is your sample standard deviation. Okay, so if you recall in the beginning of the semester, okay, when I teach you how to calculate sample standard deviation using the online calculator, okay, you have the tool where you need to divide by n-1. So there is one website which I given you the link before. Okay, if you want to calculate sample standard deviation, you need to use the appropriate option. Okay, so use that. Okay, develop the sample standard deviation, develop the X bar, and once you have these 2 information, then you can solve for question number 14. So altogether, there should be like 6 questions, if I'm not mistaken. So 28, 30, 34, and then 40. So these 4 questions are all T distribution. And then the last 2 will be 42 and 44, which are on the proportion, okay, or the Z distribution. Okay, so I think that's it for